Hello everybody, in this video we'll learn about numerical summaries for center and spread. The data on the table represents the weights of a randomly selected group of 40 male students, 13 years of age. Using Excel, I generated a summary statistics table for the data, called descriptive statistics. The raw data was summarized by the mean, median, standard deviation, sample variance, range. In the remaining of this presentation, I'll explain to you the meaning of these concepts, how to calculate them, and how to interpret them. A similar summary for the data can be generated with StatCrunch. The mean and the median are used to measure the center of a distribution. The mean is used as a measure for center when the distribution is symmetric. If the distribution is skewed or displays extreme values, then a better measure for center is the median. The median is said to be resistant to extreme values. I want you to become familiar with some notations, which are going to be used throughout this class. X bar is the notation for the sample mean. The Greek letter mu is the notation for the population mean. Let's learn how to calculate the values of the mean and median, based on sample data. To get the sample mean, you add all the sample data values and then divide by n, which is the sample size. To get the median, you put the data in ascending order. Then find the location of the median using the formula n plus 1 divided by 2. If n is odd, then the median is the element on the n plus 1 over 2 position. If n is even, then the median is the average of the elements on the n over 2 and n over 2 plus 1 positions. Variability or spread of a distribution is measured either with the standard deviation or with the interquartile range. If the distribution is symmetric, the spread is measured with standard deviation. It might be confusing because before we get to standard deviation, we have to talk about variance. To get the sample variance, calculate how far away each observation is from the sample mean. This means, subtract the sample mean out of each data value. The answer is called deviation. Then, square each deviation. The variance is the sum of the squares of all deviations divided by n-1, where n is the sample size. By taking the square root of the sample variance, you get the sample standard deviation. I want you to become familiar with some notations, which are going to be used throughout this class. The notation, the symbol for the sample variance is s squared. The symbol for the population variance is sigma squared. Because you have learned that the standard deviation is the square root of the variance, I am positive that you have guessed their notations. The interquartile range is used to measure spread when the distribution is skewed, or it has extreme data values. The interquartile range equals the difference between the third and the first quartile. We'll discuss in detail the mean, the median, the variance, the standard deviation, and quartiles in the remaining of this video. The data on the table represents the number of hours dedicated to prepare for the final exam from a random group of 10 statistics students. The mean is used to measure the center of a distribution when the distribution is symmetric. The symbol used for the sample mean is X bar. To get the sample mean, add all the data values and then divide by the sample size, which in this case is 10. Therefore, the mean is equal to 11 hours. If the distribution is skewed or displays extreme values, then a better measure for center is the median. To get the median, arrange data in ascending order. The location for the median is given by the formula n plus 1 divided by 2, where n is the sample size, the number of data values in the sample. In this example, location is 10 plus 1, 11, over 2, or 5.5. In this case there are two locations, the fifth and the sixth elements on the list, which are 8 and 11. The median is the average of 8 and 11, which is 9.5 hours. How do we interpret these values? All data values contribute to the measure of the center called mean, compared to the median, which is given just by the middle number or numbers. We say that the median is resistant to extreme values. The symbol for sample variance is s squared. To get the variance, calculate how far away each observation is from the mean. This means, subtract the mean out of each element on the list. X minus the mean is called deviation. Then, square each deviation. The variance is the sum of the squares of all deviations divided by n-1. By taking the square root of the variance, you get the sample standard deviation. The symbol for the sample standard deviation is S. Please note that the standard deviation is measured in the same units as the original data. In this example, the sample standard deviation is equal to 8.21 hours. We'll learn how to interpret the sample standard deviation shortly. If the distribution of the data looks like graph 1, we say that the data is normally distributed, or it has a bell-shaped distribution. Most of biological data is normally distributed. The elementary statistics we'll study requires the data to follow a bell-shaped distribution. There are slight variations of this distribution, being skewed right or left. The skewness of a distribution can be assessed from the relation between the mean and the median. The mean is sensitive to very small or very large data values. The median is resistant to extreme values. If the mean is smaller than the median, then you can assume that the distribution is skewed left. You can visualize that distribution in graph 2. If the mean is larger than the median, then you can assume that the distribution is skewed right. You can visualize that distribution in graph 3. On a sample of 50 randomly selected temperatures from a certain region, I used Excel to create a summary statistics table. Looking up the table, you see that the mean is 84.32 and the median is 84. When the mean is roughly equal to the median, then you can assume that the distribution of the temperatures is symmetric. The empirical rule can be applied to data that is approximately normal. That means the data has a bell-shaped distribution. The empirical rule states that if the distribution of the data is approximately normal, then 68% of the data will lie within one standard deviation of the mean. 95% of the data will lie within two standard deviations of the mean. And 99.7% of the data will lie within 3 standard deviations of the mean. You can also use the empirical rule on sample data, provided the sample data has a bell-shaped distribution. There is also Chebyshev's inequality, which describes a distribution regardless of normality. In any data set, at least 75% of the data will be within 2 standard deviations of the mean. In any data set, at least 88.9% of the data will be within 3 standard deviations of the mean. Data 1 comes from a random sample of 15 electric cars of make X and represents the mileage covered on a charge. Data 2 comes from a random sample of 15 electric cars of make Y and represents also the mileage covered on a charge. I'll assume that the distributions of both sets are bell-shaped. Based on the empirical rule, 95% of the data 1 is within 2 standard deviations from the mean. That means that 95% of make X cars cover on a charge between 139 and 335 miles. Based on the empirical rule, 99.7% of the data 1 is within 3 standard deviations from the mean. That means that 99.7% of make X cars cover on a charge between 90 and 384 miles. Based on the empirical rule, 95% of the data 2 is within 2 standard deviations from the mean. That means that 95% of make Y cars cover on a charge between 180 and 267 miles. Based on the empirical rule, 99.7% of the data 2 is within 3 standard deviations from the mean. That means that 99.7% of make Y cars cover on a charge between 158 and 289 miles. The larger range for data 1 is the result of a larger standard deviation on data 1, compared to data 2. From the summary table, you can see that the standard deviation on data 1 is 49 and on data 2 is 22. Any sample data can be summarized using the minimum data value, the first quartile, the second quartile or the median, the third quartile, and the maximum data value. These 5 numbers are called the 5-number summary. In order to construct a 5-number summary, you put the data in ascending order. Then calculate quartiles with some statistical software. Please be aware that different values for quartiles are possible if you use the TI calculator, Excel, or StatCrunch, as there are different accepted algorithms to calculate them. For our data, the minimum value is 1, the first quartile calculated with Excel is 5.75, the median is 9, the third quartile is 19.5, and the maximum value is 50. Based on the 5-number summary, you can draw a box plot. On box plot 1, the lower whisker goes from the first quartile to the minimum data value, 1. The upper whisker goes from the third quartile to the maximum data value, 50. Let's find possible outliers for the given data. IQR stands for the interquartile range, which is the difference between the third quartile and the first quartile. We'll use the interquartile range to find possible outliers, extreme data values. First, calculate the lower fence, the difference between the first quartile and 1.5 times the interquartile range. Then, calculate the upper fence as the sum of the third quartile and 1.5 times the interquartile range. The lower fence and the upper fence create an interval, in our case -14.88 to 40.13. Data values outside this range are possible outliers. For the given data, the possible outlier is 50. On box plot 2, the box plot with outliers, the lower whisker goes from the first quartile to 1, the minimum data value within the fences. The upper whisker goes from the third quartile to 30, which is the maximum data value within the fences. Based on box plot 1, I assume the data is skewed right, as from the median to the maximum value is more spread than from the minimum value to the median. As you see, the values for first and third quartiles are not the same. Excel is based on a different algorithm than StatCrunch. Both algorithms are accepted by statisticians. When you do homework, it would be better to use StatCrunch, as it looks that the accepted answer is based on StatCrunch. For these box plots, the quartiles were calculated with Excel. Interpreting the box plots, I can say the two groups of data are approximately symmetric. The median for Make X cars is larger than the median for the Make Y cars. That means that a typical electric car of Make X runs more mileage on a single charge compared to a Make Y car. Is this a good thing about Make X? Not necessarily, because I want to remind you that the possible range for Make X cars is much larger than for Make Y cars. If you are a risk taker, then you might prefer Make X over Make Y. If you are risk adverse, then you might prefer Make Y over Make X. This slide teaches you how to transform X to Z, the Z-score, and then how to transform Z to X,